So now that we know what the equation of a circle looks like, right, let's see what we can do with one. So I have the equation of a circle here, and hopefully you kind of recognize the pattern from what we talked about in the last lecture. We've got x minus a number squared plus y minus a number squared equals a number. This is the form we expect for the equation of a circle. So what I want to do is graph this. You remember when we talk about graphing the equation of a line, you always need to know two things. Ultimately, you need to know the location of 2 points on the line, then you draw the line connecting them. And sometimes you actually have the 2 points, sometimes you have the point and the slope, and you have to kind of figure out the second one. Ultimately, it comes down to 2 points. There's a similar situation with the equation of a circle. To graph the equation of a circle, we again need to know two things. We need to know where's the center, and we need to know what the radius is. All right, well, underneath my equation here, I'm going to write our equation of a circle. Remember, it looks like x minus h squared plus y minus k squared equals r squared. So notice how things match up. H just matches with the 2, k matches with the 3. So there's my center. The center of my circle is at 2, 3. Now the r bit you have to be a little careful with. 12 is not the radius. 12 is the radius squared. So r squared equals 12. R is the square root of that. R is the square root of 12. Because we're graphing things, I don't necessarily want to simplify this so much as I really am going to need to make it into a decimal. Right? So if you go to your calculator and you ask it what this is, it comes out to approximately 3.4, which for graphing by hand purposes, might as well be 3.5. We'll get somewhere close to that. All right, so now how do we do the graphing bit? Well, first, I'm going to go to the center. That's over 2 and up 3. That's right there. And I know what my radius is. It's 3.4. So in the end here, we're going to have to freehand a circle, which can be a little tricky for some people. But what I'm going to do is I'm going to say, look, the radius is 3.4, right? So I'm going to go 1, 2, 3.4 to the right of the center. I'm going to go 1, 2, 3.4 to the left of the center. Then I'm going to do the same thing. I'm going to go up 1, 2, 3 and about a half, and I'm going to go down 1, 2, 2, 3 and a half. Those 4 guide points, if you will, are all on the circle. So if you sketch a circle, this is actually easier for me if there are fewer points. So if you can do this with fewer points, that's fine. And there is the circle. If you really want to be technical about it, I don't know how picky your professor might be, you maybe take that center point out because that point isn't actually on the circle itself. So what's left here is going to be our equation, and that's it. Right? That's all there is to it. Okay, I say that, but what if our equation looks like this? Okay, this is not in the useful form, right? Not where I can just grab my numbers. I need this to look like x minus h squared plus y minus k squared equals a number. All right, so how can I make it look like that? So the first thing let's just do a little rearranging and watch how I do this. I'm going to do x squared plus 4x. Leave a space here. If you're taking notes, you're following along. I'm going to put a number in there in a minute. Plus y squared minus 8y. Again, leave a space. Equals negative 2. I'm going to go ahead and move that 2 over to the other side. I know I want the pure number part to be on the right, so I'm going to go ahead and get that over there out of the way. Okay, so now what I'm going to do. Now I need to make this into something that I can factor and look like x minus h squared. Maybe there's a plus in there, but I need it to be a perfect square. You remember, we have a method for turning a polynomial into a perfect square. It's called completing the square. Right? And you remember how we do this. I'm going to take the number that's in front of the x. That's the 4. I need a little scratch paper over here. I'm going to take the 4, divide it by 2, and square it. 4 divided by 2 is 2. 2 squared is 4. So I know that if I add 4 to both sides, that part becomes a perfect square. This is now x plus 2 squared. And I'm going to do it again, right? I need a little scratch paper here again for a second. I'm going to do negative 8 divided by 2 squared. Remember, negative 8 came from right here in front of the y. That is, let's see, negative 4 squared. That's 16. So now I'll add 16 to both sides. And this y part now factors. This is y minus 4 squared equals, let's see, that's 20 minus 2. That's 18. Okay, good. Now I have the form I can work with. But again, there's a little bit of a twist here. Remember what our equation looks like. X minus h squared plus y minus k squared equals 18, which will be r squared. We'll get to the r bit in a minute. Now, the signs here are important. Over here on the y side, both numbers are negative. That's why I can just say, okay, look, k equals 4. Okay, but over here I have a problem. Over here, my signs don't match up. I've got a plus on one and a minus on the other. Okay, so here's how I want you to think about this, right? Let's rewrite this x plus 2. Let's make this x minus 2 squared. And now everything matches up. Now I have two minuses here in the middle, and h is just negative 2. So the coordinates of my circle, the coordinates of the center, are negative 2, comma 4. Okay, now that's a lot of work, right? And as you do this and you get the hang of it, you kind of just get into a rhythm, and you know, okay, the coordinates of the center are the opposite of the number. So I have a minus 4 here, which meant the y coordinate was positive 4. And I've got a plus 2 here, which means the x coordinate is minus 2. You don't necessarily have to go through this minus 2 thing every time. Certainly not once you start to get the hang of it. Okay, so then the last bit, r squared, is 18, which means r is the square root of 18, which is somewhere in the neighborhood of 4.2. You can go to calculator and check me on that. There's really, since we're going to be graphing, right, there's really not much point in going out further than one decimal place. All right, so now I can do my graphing. The center is at negative 2 over negative 2 up 4. That's right here. And I'm going to do the same thing I did before. I'm going to go 4 units plus a little bit, and all 4, 1, 2, 3, 4, and all 4 kind of cardinal directions. And this will be down here just a little bit below the x-axis. 1, 2, 3, 4, a little bit above that line, and then you very carefully sketch in, to the best of my very limited ability, your circle. And again, if you want to be super technical about this, you can take that marker you use for the center out, because that really isn't technically on the graph. All right, so I got one more here. And if you like, if you're following along, you go ahead and pause, or maybe try working this one out on your own. There is a little something interesting, different to it, but you're welcome to give it a shot. Then come back and see how I approach this. All right, so I'm going to do the same thing I did before. I'm going to regroup a little bit. I'm going to put the x's together, leave a space here, so I'm going to add my number, plus y squared. You notice there's no y term here. And that's what kind of makes this one a little interesting. And I'm going to move the 4 over. All right, so on the 7 side here, remember what we do. I'm going to do my little scratch bit here. Negative 7 over 2 squared is 49/4. So I will add 49/4 to both sides. And now I have to factor this bit, and I know it's weird. We're not used to factoring things with fractions in it, are we? But remember, when you're doing this, there's a slick little trick. The bit that goes here after the x is the same as this part right here, right? So this is going to be x minus 7/2 squared plus y squared equals, let's see, 4. That's 16/4, right? 16 and 49, 50, 64. Did that really come out even? 56. No, it didn't. I'm not that lucky. Sorry. 56 and 9, that's 65 over 4. Okay, so where is my center? So what happens with this y bit? I know that the x-coordinate of the center is 7/2. Again, remember, it's the opposite, right? So I've got negative 7/2. The x-coordinate of the circle is positive 7/2. Well, look, if there's no number over here, what do we do when there's no? How do we say no number? Well, it's just 0. In fact, if you really want to force it, you could think of this as y minus 0 squared, and now it completely matches the pattern. Okay, so there's my center, and my radius is the square root of 65/4. Okay, now you can go to your calculator if you like. But remember, we're doing an approximate decimal value anyway. So look, as long as I'm approximating, 65 is really close to 64. 64 divided by 4 is 16. The square root of 16 is 4. So my radius is going to be really pretty darn close to 4. And now I know everything I need to know to graph this. I'm going to go over 7/2. That's 3.5 up 0. Then I'm going to go 4 in every direction. 1, 2, 3, 4. 1, 2, 3, 4. And you can go down 4 and up 4. Then here comes the heart. You know what? I really can free-handed circle pretty decently, but trying to do it and hit 4 points is really kind of hard, right? So I'm just gonna say it looks. Whoa, I lost my pen. Let me try that again. It looks like. That wasn't much better, but you get the idea, right? You sketch your points in there, and then I can't help but try that again. Has to go down to here, right? It's just going to look more like this. There you go. That's a little more like it. Then, if you like, you can take that center point out, since that isn't actually part of the circle. Okay, so that's how, if you're given the equation of a circle, that's how you kind of manipulate it, get some useful information from it. In the next lecture, we're going to go the other way. I'm going to give you information about the circle and say, okay, now find the equation that matches that information.